Okay, so hello everyone. I hope you've been having a great event at Web3 Festival so far. So the thing that I want to talk about is a very important topic for Ethereum and its ongoing infrastructure development, which is the future of the Ethereum L1. So let's start off by talking about where Ethereum is in 2025 today, right? So today we have about 15 transactions per second at layer 1, right? So we have the gas limit recently increased to about 36 million, and it's increased by probably about a factor of 6 over the last decade. And there's a lot of applications that are happening on it. I mean, increasingly seeing a lot of interesting things happening in DeFi, decentralized social, prediction markets, all kinds of different use cases. And we've been, yes, hello. And we've been seeing like just the technology continue to mature, the technology continue to become more stable, and at the same time, we've also been seeing about 250 TPS at layer 2, right? So layer 2s have really been speeding ahead in terms of enabling Ethereum scalability, and scalability is something that is really important for our users and just for people's ability to build actual things on top of Ethereum, right? So just one simple example, remember 10 years ago, people were excited about building decentralized Uber on top of Ethereum. And if you think about decentralized Uber, well, imagine you make one, and let's say it has 100 million users, and let's say on average, each user sends or goes on a ride once per day. So let's say you're sending one transaction per day for 100 million users. In a day, there's 86,400 seconds. Divide 100 million by 86,400, and you get about 115 TPS. Ethereum L1 today can still handle 15 TPS, but layer 2 currently can handle 250. So short term, layer 2 has really been growing quickly, and it's been taking on this burden of making it possible to quickly scale Ethereum applications today. And the good news is that in 2025, it's getting much, much better, right? So I have this picture over here, and actually, the 250 TPS number, that's the number at the very bottom of the curve over here, right? So today, we have 3 blobs. 3 blobs is about 375 kilobytes. 375 kilobytes per 12 seconds, about 30 kilobytes a second. Divide by size of a transaction, you get your 250. But this is all before all of the things that we want to do over the next 2 years, right? So Pectra, the next hard fork, will increase the blob target from 3 to 6, and so the 250 TPS will become 500. Then in ETHAsia, the ideal goal is to get to 48. I think there's a couple of different possibilities. It could be less, it could be more. A lot of it also depends on whether we want to target ETHAsia in Q4 or be more ambitious and do it in Q3. But the goal is that once we roll out PeerDAS, the data availability sampling technology, we can start increasing the amount of blobs very quickly, right? And then if you push PeerDAS to the optimal level, you can get to 128 blobs. And then if you get to full 2-dimensional DAS, you can get all the way to 512 blobs, right? So we're talking about many tens of thousands of transactions a second possible on layer 2 and happening pretty quickly. In addition to this, also EIP 7702 making a lot of progress. Basically, a big first step in account abstraction, allowing accounts to be smarter, more secure, and do more things in a more decentralized way. So this is all a lot of progress on L2, and this is the result of many years of research, many years of development and work. So that was scaling L2. One of the other really big and really important things that we want to do is we want to scale the L1, right? So what I'll talk about a bit later is a series of steps that we can use to actually increase the gas capacity of the L1 by a very similar amount. So one question you want to ask is, well, why do we need to scale the L1, right? Is L2 not good enough for everyone? And I think there's a couple of reasons here, right? So one of them is that even in a world where everyone is using L2s, actually there's a lot of features that L1 still needs to provide, especially if you want those applications to actually be secure, right? One of the big differences between an L2 and a separate L1 is that you still have some kind of recourse if the L2 fails. And so if the L2 fails, then like users will be able to mass exit, they'll be able to move to a different L2, they'll be able to submit fraud proofs. So all of these things, they require some amount of L1 gas. Also, if an L2 starts refusing to include your transactions, you might need to use L1 censorship resistance features. Then moving assets between different L2s, issuing things on L1, also key store wallets, which store your wallet information on L1 so that if you update it, you don't have to update it hundreds of times on each L2, submitting proofs. All of these things, for them to become cheaper, for them to become viable at a large scale, it turns out L1 actually also has to scale by quite a bit, right? Now also, what if we scale the L1 even further, right? So there's a roadmap that's not too difficult by which we can scale the L1 by about 10x. And so we could get the 15 up to 150. And so if you really want, you'll be able to run a full-scale mass market decentralized Uber directly on the Ethereum L1. Or you'll be able to have a really huge number of different hybrid L1, L2 applications that use L1 for what it's best, use L2 for what it's best. What if we scale the L1 even further, right? So the same kinds of techniques that scale the L2, those same techniques can be used to scale the L1, right? L2s scale by taking advantage of the asymmetry between production and verification. The fact that a block can be much, much easier to verify than it is to generate. And so L1 could actually use the exact same technology. So if L1 scales even further, I think one interesting question is like, what are the things that L2s will continue to be responsible for? And I think there's three good answers here, right? So one is hyperscale, basically scaling even further beyond what the L1 is with its data availability. Two is sequencing. So this is like choosing the order of transactions. So this is useful for two reasons, right? One is that there's a limit on how low the latency of the L1 can be. So today, slot time is 12 seconds. In the future, we can reduce it to 8 seconds, ideally 4 seconds. But even 4-second slot times for many applications are not good enough, right? Like if you imagine taking a game and putting the game on chain, and then imagine like you would sometimes just have to wait for 4 seconds, the game would freeze, no one would be able to do anything for until the next slot, right? Layer 2s can help here. Also, Layer 2s can protect users from MEV exploitation. And then the third answer is experimenting with different technology, different VM designs, things like Arbitrum stylus, right? So a lot of value there. So short-term 2026, right? Basically, there's a series of proposals that by which we actually can increase the gas limit of the L1 very significantly and do it safely without compromising on node decentralization, right? So one of them is a block level access list. So this basically says a block has to specify, it has to contain the data that it accesses, right? So if a block moves, like say 1 ETH from my account to another account, it has to contain what is my address and what is my balance. The reason for this is it lets you parallelize EVM and I/O, right? So it lets you separately do EVM execution and do reading from storage. Then delayed execution. This lets you execute blocks in the next slot instead of in the current slot. And this makes it safer to increase the time spent executing from about 200 milliseconds to potentially 3 to 6 seconds. Multi-dimensional gas for call data, so setting separate limits for execution and for data. This makes it safer, reduces the theoretical maximum size of a block. EIP 4444, which basically means instead of requiring every single node to store the Ethereum history, we use peer-to-peer networks, and we can store the history in a more distributed way, right? And then on top of this, we have Fossil, which is a censorship resistance feature. Basically, it means even if only relatively large nodes are producing blocks, little nodes would still be able to contribute transactions, and they would be able to force those transactions to be included in the next slot. And then also on top of this, account abstraction. So, and then later on, statelessness, state expiry, and then finally using ZK Snarks to verify the EVM, right? So the big takeaway from all this is that there's this entire row of technical improvements to the L1. These things have been researched for years, they've been worked on for years, and the end result of them is basically that we can pretty massively increase the amount of activity that can even happen on the Ethereum L1 using very similar techniques in a lot of cases to what L2s are already doing today. So scaling is not the only thing that matters, right? I think in general, we're trying to make Ethereum ready for mainstream large-scale applications. And if we think about this from an L1 perspective, we have to think about the question, well, what does the L1 need to do? What does the L1 need to be? So that if you build that kind of application, L1 can actually support it. So scaling is one of those really big factors. Another big factor is account security, right? So today, a user account is basically controlled by one single private key. And so either you own the private key, and then you have to constantly be worried about what happens if you lose it or if it gets stolen, or someone else controls the private key for you, and then you have to trust them. With account abstraction, we can greatly expand the set of options for users to get more security and more self-sovereignty for their assets and better user experience at the same time. You'll even be able to do things like, for example, say, if you want to make a transaction with less than 1 ETH, you need 1 key. If you want to make a transaction with more than 1 ETH, you need 2 keys or you need 3 keys. So these are basic things that have been experimented with in traditional finance for a long time. And with account abstraction, like, we can actually start to include them into wallets that users have by default. Quantum resistance, we need a quantum resistance strategy. Account abstraction lets you specify any verification function for your account, and so you can verify quantum resistant signature algorithms. Paymasters, so you can have other people pay for your gas. You can pay for your gas in currencies other than ETH. So this all makes a smart contract wallet properly a first-class citizen in Ethereum, right? And generally, I think the strategy here is that L1 needs to lead, because these are things where L1 and L2 all really need to upgrade at the same time, right? And so if L1 leads, it makes it much easier for L2s to follow along. Now, this diagram I have over here, basically, this is this whole concept of guardians, right? This is something that's been making a lot of progress in the past year. Basically, the question that we're trying to solve is, one of the big things that crypto offers is it offers this high level of decentralized security, ownership, self-sovereignty over your digital assets, right? So you control your digital assets, and your control over your digital assets does not depend on trusting a centralized authority, because, as we saw with Mt. Gox and FTX and many others, centralized authorities can fail. And so the question is, well, how do you not rely on a centralized authority, but at the same time, how do you avoid putting too much burden on individual users to do things that are very technically difficult for them? Like, maintaining ownership of a single private key is technically difficult for people. And so the social recovery and guardian concept basically says, well, we have an account where in that account we specify some number of different guardians. Could be 3, could be 5, could be any number. And these guardians can actually be a combination of different things, right? They can be keys that you control. They can be hardware wallets. Over the past maybe 2 years, we've had a huge amount of progress in technologies like ZK email, which actually lets you create a smart contract account that can only send a transaction if you prove that you have control over an email address. We also have ZK wrappers for government ID, so you can do the same thing for a government ID. And so also, basically, we can take advantage of things that people are already used to in Web 2, accounts that people are already used to dealing with, and we can import that trust into Web3, and if we make them one of the guardians of an account instead of making it the whole account, then you're able to put some limited amount of trust into them without actually putting all of your trust into any one particular institution. So the space for us to really innovate and really like push the frontiers of decentralization and leveraging trust that already exists in the real world is like increasing by quite a bit, right? So then what about everything else, right? So L1, some increasingly discourse about what L1 can do to support privacy more. So that's a lot more native support for cryptography. Account abstraction work feeds into that. Upgrading the EVM. Also cleaning up the protocol, making the protocol simpler over time. It includes virtual machine stuff. It includes like protocol serialization stuff. Single slot finality, so simplifying the Ethereum consensus algorithm, right? So basically, over the past 10 years, we've learned a huge amount about how proof of stake consensus works. And I think 10 years we were still in this very early stage exploring mode, and now we roughly understand the design space. We roughly understand what's optimal, what can be done, and what can't be done, right? And so we can actually take some of those learnings and we can create an ideal protocol that combines quantum resistance at the consensus layer, that combines ideal levels of security. So 50% for synchronous networks, 33% for asynchronous networks, and that has the Tendermint-like finality properties, and at the same time, LMD Ghost-like liveness properties, and that is maximally simple, maximally fast at the same time, right? So these are all things where we've had proposals for about 2 years, increasingly going into implementation. If anyone is interested in contributing to this, the Beamchain teams have become increasingly active. Feel free to reach out to Justin Drake. He loves nerding out about this stuff even more than I do. So a lot of like really amazing stuff happening at L1, right? So what is the final goal of all of these things to me, right? To me, the final goal is that we want the Ethereum L1 to be the core of the world computer. We want it to be this central place that applications, including financial applications, including social applications, including identity-related, like including things that use the chain as a place to store data. We want all of these different applications to be able to trust the L1, and we want it to be something that can be reliable and really sturdy and stay for a long time. And at the same time, we want it to be powerful enough to actually meet users' needs, right? If you have an ultra secure, an ultra simple, an ultra clean L1, but the L1 is not powerful enough to do anything, then all the applications will move somewhere else. And so all of the applications, they will not actually be able to benefit from the amazing properties that the L1 gives you, right? And so we need to improve the L1 both on security and decentralization and on efficiency and scale. And this is what we're doing. And then this is part of this integrated effort, right? That's about improving the L1, improving the L2, improving wallets, thinking about different ways to access the Ethereum chain, including AI-based ways, improving the application layer to really push the Ethereum ecosystem so that we can actually achieve all of the things that we've been talking about, what we want to do with Ethereum, and do so within several years and do it very quickly and at scale. Thank you.